Hi, so I decided to do my experiment on upwelling and downwelling, which is basically the process when wind blows on the surface of the water, pushing warmer water to down, creating an area of low pressure, which causes colder, more nutrient-dense water to come up to the surface, pretty much dispersing nutrients and the temperature change. So here I'm simulating the kind of moderate ocean temperatures, like the surface water almost. And then right here in this ice bath, I have my cold water, which is supposed to be like the colder, denser water at the bottom. And I put a little bit of salt in this to also mimic salinity, but you don't have to do that. So I'm using a mock pipette because I don't have one of those. And so I'm just gonna put the cold water kind of down. And because it's colder, it's gonna sink to the bottom. So I have to do this a couple times. Oops. So again, just kind of sink into the bottom because it's pretty cold and a little more dense than this water. So we already learned this in class, so the really big difference that's going to be showing is the wind effect. So I'm going to kind of show how a coastal wind, a wind coming from the coast would affect it. And as you can see, it's more dispersed, and a lot of the wind kind of pushed it up, the colder, more dense water up, just kind of dispersing the temperature and the salinity. Not the salinity, well, yes, the salinity too. Dispersing the temperature and nutrients in that water. So now the opposite would be downwelling. Yeah, and that's basically when the surface water is pushed coastally from offshore winds. So if I had this, yeah, the surface water sinks and the colder water comes up. And always this process really disperses nutrients and creates a more ability to thrive for marine life. So it's a very important process, and it's great for regulating temperature and nutrients among sea life. Thank you.